Hello and welcome to Telecom Training. In this video, I'm going to show you how to subnet Class C IP addresses. Here we have an IP address 203.67.24.0 and we have a subnet mask underneath 255.255.255.0. Now, anytime you see a Class C subnet mask with .0 at the end, this tells you that this is a full range. So this tells you that this IP address would go from 0 to 255. So you will have 203.67.24.1.2.3.4 right up to .255. Now, the very first IP in the range, .0, would be the network, and the last one would be the broadcast, which is the .255 IP. If you want to assign all of these IP addresses to the same network, that is fine. You could assign this as it is to one network. In most cases, when a company goes out to an ISP and buy a full range, they actually want to use this full range of IP addresses among many networks instead of just one. So this is where subnetting comes in. I've used an example down here of 30 branch offices. You want to divide this network into 30 branch offices, and each one of these branch offices will have its own network and broadcast IP address as well. For the first thing we have to do is to come up with the binary equivalent of 30. I'm going to show you how to do that in a minute, but first I want to show you simply how we came up with the binary equivalent for 255. You were probably wondering what these ones here is all about. Now, each one of these ones here represent a bit, and there's 8 bits that makes it the number 255. So the numerical value for each one of these bits are listed right here in red. The very first one is 1, 2, 4, 8, 16, 32, 64, and 128. Now, if you add the numerical values for all of these bits together, you will get the number 255. This is how we get the subnet mask of 255. So we have a question mark here because we know we 255.255.255, but we're not sure what the last number will be. And this is what we're going to work out right now. So we have to change this 30 to binary. We got to find out what's the binary equivalent for 30. So we'll go up here, and we know that 128 is much bigger than 30. So we'll put a 0 there. It won't be a 1 like we have up there for 255. That would be a 0. We know that 64 is much bigger as well, so that would be a 0. We know that 32 is bigger, so that would be a 0. We know that 16 is smaller than 30. So we'll put a 1 right under 16. 16 plus 8 is 24, so we'll put a 1 there. Plus 4 is 28, a 1 there. Plus 2 is 30, so that would be a 1. We have already got all the numbers we need to make up the number 30, so the last one would be a 0 under the 1. So if you looked at this, how many bits would you think this will be? Looking at it, you'd probably say 1, 2, 3, 4 bits because they're 4 ones, but they're actually 5 bits. We count the 0 as a bit as well. Anything after this first one is a bit. It doesn't matter if it's 1 or 0. So we're going to take all 5 of these bits and move them from the end and move them over to the beginning here right now. So this is how we do it, like this. 1, 1, 1, 1, 1. You probably think right now, oops, you made a mistake. You should have put a 0. No, I actually did that on purpose. Anytime you have a 0 over here, the 0 could be the second bit, it could be the third, or it could be the last. You always change it to a 1 when you move it over. Okay? So now we have our binary equivalent for the subnet mask. we have to figure out what is the numerical value of this binary number. So I'm going to get my calculator out right now, and we're going to work that out together. So we have 128 plus 64. The second bit is 64 plus 32 plus 16 plus 8, right? So that would be 248. So the number here would be equal to 248. So I'll put that number there, 248. And also here, the subnet mask will be .248. So now we got a subnet mask of 255.255.255.248. Now this subnet mask is what we're going to be using for all 30 branch offices. Each one of the networks within these branch offices will have this subnet mask. So now we know the subnet mask. What is our next step? Well, the next step is to find the first IP address in each network range. Well, we already know what the first IP address is, and it's this one, 203.67.24.0. So I'll put that in here right now, okay? 203.67.24.0. So that's the first IP address in the first range. So this would be like the first branch office, the first IP address within that range, okay? We still have to find out what the fuller range is, but first we're going to work out all the first IP addresses for the ranges. So the next one, what will the network IP be for range number 2? Well, the way we would work this out, we will go back to the binary code here, and we'll look for the least significant bit. We know this first one here, 128, is the most significant bit. So 8 is the least significant bit of this code. So we'll go back here and we will type 203.67.24.8. The range is now 8 because the least significant bit is 8. And now for range number 3, 203.67.24.16. And for range number 4, you see we adding 8 each time, 203.67.24.16. Okay? 24.24. Sorry about that. So we have so we'll keep on going. The network, the next one would be 203.67.24.32 and so on and so forth. And we'll keep going until we get all 30 ranges. But I run out of room here, and basically I think you got the idea of exactly how that will be. So the next step will be to find the full range for each network assigned to the branches. So looking at network number 1, what do you think the full range will be? Well, it would be 203.67.24. What's the number that comes before 8? 7, right? Not a trick question. Yep. There we go. The full range for this first network would be 203.67.24.0 to 203.67.24.7. .0 would be network, .7 would be broadcast. Now from .1 right to .6 will be the usable IP addresses for this network. And the subnet mask will be 255.255.255.248. So we have everything we need for network number 1. Let's take a look at network number 2. It will still be 203.67.24. The number that comes before 16 is 15. So dot 8 will be the network, dot 15 would be the broadcast, and from dot 9 to dot 14 will be the usable IP addresses for that network. The next one will be 203.67.24.23. And just like before, 16 would be the network, 23 would be broadcast, and from dot 17 right up to dot 22 would be the usable IP addresses for that network. So basically, this is how it would be done right up to the 30th network. For the 30 branches, you would calculate them in the same way in order to get all the IP ranges for all 30 branches. I went ahead and I drew up a little diagram for you showing you branch office number 1 and branch office number 2. Now branch office number 1, I have a network range between 203.67.24.0 right up to dot 7. And you'll notice here that I have dot 0 being network, where I have the N, that's for network, and B is for broadcast. So dot 7 is the broadcast. And from dot 1 right up to dot 5, I'm using for the servers, and dot 6 I'm using for a router. And you'll notice here that the subnet mask is 255.255.255.248 for all of the devices on this network. Now you'll notice that branch office number 2, which is right here, 203.67.24.8 to dot 15. Now dot 8 is for the network and dot 15 is broadcast, and we're assigning to devices from dot 9 right up to dot 14. And the subnet mask is the same, 255.255.255.248 for all the devices on this network. This was the first in a series of videos on IP subnetting. The next one would be subnetting class A IP addresses, and then we'll be looking at another video subnetting class B IP addresses. Now if this video has been helpful to you, don't forget to click on the like button below. It's very helpful. And also, if you haven't subscribed as yet, please don't forget to click on the subscribe button below, and also click on notification so that you'll be alerted as soon as our new videos are released. My name is Trevor from Telecom Training. Thank you for watching.